So in previous part, in part 1, we have seen about design has set. Now, design has map is a continuation of this design has set. If you don't have any idea about design has set, just go and watch it, then continue with this has map. So it is a continuation, okay? Just see here. We want to implement my has map, and this my has map is initialize the object with an empty map. Okay. Then void put is used to put a key value pair. Then void get is used to get the value of the respective key, and void remove is used to remove a key value pair. Now, let's discuss about this example. See here, in this example, they have given first a my hash map. So they have declared an object. Okay. Now, put of 1 comma 1. So let us take a hash map. Now 1 comma 1. So one is a key and one is a value. So it is what? Key and value. So it is a key value pair. Now put of 2 comma 2, which means 2 is to 2, which means 2 is a key and 2 is a value. Now again, get of 1. So what is the key 1? Key 1 is here, right? Here. And what is the value? It is 1. That's why they have written what? 1. Fine. Now get of 3. Whether there is any 3 present here? No. So don't do anything. Just skip. And return what? -1, because there is no 3 present. Now put of 2 comma 1. So we can put 2 comma 1, sorry, 2 as key and value as 1, but already 2 exists, right? 2 is existing already. So just modify this 2 as 1. Can you understand it? Can you understand? No. Next, get of 2. Now what is the modified 2 value? It is also 1. So that's why they have written 1. Now remove of 2. Okay, let's remove this 2. So remove it. Now get of 2. Whether there is 2 recently now removed, right? So there is no 2 present in this hash map. So we will return what? -1. So that's why the answer is -1 here. Can you understand till now? Okay. So this is the basic hash map. Now in hash set, we declared as a node, right? We just done it by using a hashing, right? We done it by using the hashing concept by using what? Linked list. We done the hash set, right? In a hash set implementation, we used the hashing and linked list concept. Similarly, in HashMap also, we are going to use those concepts. You may ask how. Here's the example. See here. In hash set, we have seen a node can contain a value and a next address. But in HashMap, it is very, very important. In HashMap, a node contains a value, a key, and a next. You can also interchange it, no matter. But these are the 3 attributes we have in a hash map. So how my class going to looks like? Inside my class, we have 3 data members. What are those? One is key, another one is value, another one is like next address. So this is my structure of my class for node. For single node, it is going to the structure. Now, the next step is we are going to do some of the operations, right? What are the operations? Get, put, and remove. Fine. Now, first we can see get operation. Get is easy, right? Okay, get operation. First, if I have some values, right? So take for example, this is our given key value pairs, and this is our hash map array with a linked list. This I already told in the hash set also. Okay. Now just observe here. What is my hashing value of this 30? 30 mod 5. So which is equal to 0, right? Again, if you haven't watched my hash set video, then it is more complicated. Fine. So 30 I stored in a key and 2 I stored in a place of this value. Now hope you understand this concept, right? Fine. Now like this array is constructed. So this is what? HashMap. What? HashMap. Okay. Now let us assume we are going to get a key of value maybe 41. Okay, or we can get for 10. 10 is at here, right? So 10. Okay, what is my hash value of 10? So hash value of 10 is 0, right? Because 10 mod 5 is equal to 0. Okay, so I'm going to here. Fine. Okay, I'm checking here. What is my value? It is 30. No, 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 no. So go there. Again, it is 0. No, 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 no. Again, go there. Yes, it is 10. It is 10. I found 10. So I will return the value. So what is the value? It is 2. So what is my output? It is 2. Okay, fine. Now let us see for key value of maybe 23, right? So 23 mod 5 is equal to 3. So it is our hash value. Now going to the 3. Okay, now checking whether it is 23. No. Whether there is anything else. No, there is no node present. So I can say there is no key called 23. So stop there and give me output as what? -1. I hope you understand this get method. Now we are going to see about what? Put and remove, right? Now we can see about remove method. It is quite similar. Like get method is simple. Now see, so I may write here. See here, put method. Now, sorry, remove method. Remove method. Confused. Okay. Now I'm going to remove 10 key value as key value. It's not key value. It is keys value. Okay, is 10. Now what is my 10's hash value? It is 0. So I'm going to 0. Now I'm checking whether this 30 is 10. No. Whether this 0 is 10. No. Whether this 10 is 10. Yes. Yes. So I want to delete this, right? If I want to delete this, first what should I do? I should do, I stop here. Then I want to make this connection as none. That's it. I delete, right? If I make this connection as none, I will definitely delete it. That's what I have told in the introduction video. In part 1 itself, I told you clearly that you have to see about the linked list introduction video of insertion deletion. If you don't know linked list insertion deletion, this is so complicated. Okay. Now, if I want to delete this node, I have to stop here itself. Okay. Then if I want to remove this link such that this node will be deleted, right? And I want to connect this link to the next node, which is what? Here it is none. Here it is none. So I will connect to this none. I will take this connection and connect to none. That's it. If I want to delete this 0, then what I do? I take this 30's next and connect with this 10. Up to this clear, right? Okay. By doing this, I can remove this node. Okay, fine. Now, if I do remove of, take for example 23. Okay, 23's hash value is 3. So I am going here. I am checking whether 13 is 23. No. And I am going further. There is no 23. There is no 23. So just don't do anything. Just leave it. Fine. And also, see here, if I want to stop here, stop at one node before, then what is the procedure to do that? See here, in hash set also we done the same thing, right? We will take this as current and this as previous and updating one by one. First, previous is at none. Here, first of all, previous is at none. Let's take example. I clearly stated this in previous part 1 itself, but still I'm going to tell this once more. If you don't want, you may skip. See here, initially it is like this. If I want to delete this 1, then it is easy. I will take this 2, I'll take this 2 and replace as our index value. Okay, like current is equal to current dot next, and I will replace that in our value. It is like deletion at start, delete at start. Okay, if I want to delete this 2, then I will make this current to go here and also pre to move one step ahead. Whenever current is moving one step ahead, pre also one step ahead, so that current and pre will point to the current node and pre to the previous node. Now, if I want to delete this 2, then what should I do? I should do like, I will take this connection and connect to this 3 such that it is deleted. That's all. Okay, so pre dot next is equal to current dot next. That's it. Now hope you understand this remove. Now it's time to go to get. So sorry, put. Just take for example, this is our HashMap now. Okay, now I want to put maybe 15 comma 3. Fine. Now, what is our hash value for 15? I can say hash value for 15 is 0. 15 mod 5 is obviously 0. So I will go here. Okay. First I am checking whether this 30 is equal to this 15. No, it is not equal to 15. Okay. I am going here. Whether the 0 is equal to 15. No. I am going here. Whether this 10 is equal to 15. No. Okay, you may ask, why are you going and check on? Because in this put we have two conditions. What if already exists? And what if it is not already exist? So we want to go up to the end and we want to check whether is there is existing element. It is an existing element such that I'm going to checking it. Okay. Now 10 and I'm going here. No, none. So stop there. Stop there. There is no such element called 15. That means there is no such key called 15. So what I'm going to do is now I'm going to create a new node for this and putting 15 here, then 3 here. Okay. Now I'm going to connect this to the starting node. So this starting node and setting this as our 0 in this. Can you understand? So I'm just connecting this and setting this as our 0 in this. This is what we exactly done in the hash set also. Now, if take for example put of maybe 41 comma 2. If I am giving 41 comma 2. So what is the hash value? I can say hash value is 1, right? Go to the 1 and check whether this 41 is equal to 41. Yes, it is equal. So what should we do? Just take this 0 and replace as 2. That's it. Don't do anything. Just return it. Now hope you clear these three operations. Now it's time to see the code. Just see here. I have the code. In previous hash set also we took the array size as what? 1000. For example only I done for 5. I cannot draw for 1000 cells. So in real time we are going to do about 1000 cells. Okay. Now class list node def init of self comma key is equal to 0, value is equal to 0 and next is equal to none, which means key and value we are going to give us an argument. Now self dot value is equal to value, self dot key is equal to key, self dot next is equal to next. So this is only changed while comparing to what? While comparing to the hash set. Wherever there's a change, I will give like changed. Okay, by seeing that you may analyze what are the change I have done from the hash set and HashMap. Both are similar. Fine. Now again, class my HashMap def init of self dot size is equal to 1000, self dot container is equal to none into self dot size. Same as a hash set. Now def put of self comma key then value. Now hash value is equal to key mod self dot size. Okay, current is equal to self dot container of hash value. Fine. So we have taken the first node of the required hash value. Now I'm going to traverse on while current is equal to none. Up to current going for none, I will traverse. Okay. Now if current dot value is equal to current dot key is equal to key, which means what? Which means if I found that key it is already exist, then what should I do? Current dot val is equal to value. That's all. Written. Easy, right? Now current is equal to current dot next to iterate one by one. If this loop exceeded successfully and the control flow comes to here, then what should I do? I should create a new node. I should create a new node of key and value. Then that new node next should point to the first node of that hash value. That's what I have written here. Now that first value of the hash value should be updated to what? Updated to temp. Hope you understand till now, right? Now again coming to this get function. Now inside this get function I put key, then hash value is equal to key mod 1000. Now we got the hash value. Now current is equal to self dot container of hash value. So we are at the starting value of the hash value container. Now while current, if current key is equal to key, which means what is the meaning? What is the meaning? I found that key. In such time, what should we do? We should return current dot value. That's it. That's it. We already existing that value. So I written that node's value. That's it. And current is equal to current dot next. If this loops executed successfully, then there is no such element, right? So I will return what? -1. That's it. Now remove function. Inside this remove function also, first two lines is same. And I said you right, we will get pre is equal to none and current is equal to the first node. That first node. And we are go on iterating one by one. We are go on iterating one by one. That's why I used what? Pre is equal to current, then only current is equal to current dot next. So that first of all, pre comes here, then current goes here. So that they will maintain like previous node and current node, previous node and current node, like that. Now, if current dot key is equal to key, I got the value. So that's the node I have to delete, right? So now comes a condition. If pre, which means if pre is not equal to none, then what should I do? Pre dot next is equal to current dot next. If it is none, then it is like not delete at the start node. So self dot container of hash value is equal to current dot next. That's it. First value is skipped and we take in the second value, second node itself. That's it. So this is what the important condition, and I already told this in the as set also. So this is the end of the code. Now let's submit it. Yes, it is submitted successfully. Thank you.